Hi everybody, this is the paper 2 from November 2019. So if you're practicing these, then hopefully this will help you if you're getting stuck. So let's have a look at question 1. Frequency polygon is not fully correct. So let's take a look at what that looks like. Okay, so one of the first problems is that you wouldn't connect these points here. You would leave that open at the bottom. There's no label here. And let's check the points. 10 to 20 is 6. Yeah, so that's a little bit high there. So yeah, you could write down 2 of those things for the marks there. The length of a pencil correct to the nearest millimeter. So with our accuracy, we always look at this, and then we go plus or minus a half of whatever that accuracy is. So the nearest millimeter, we go plus or minus a half of the nearest millimeter. So we're going to go up half a millimeter to 128.5 and down half a millimeter to 127.5, like that. Tom and Adam have a total of 240 stamps. The ratio is 3 to 7. So we always just add those and divide the total by that amount. So 240 over 10. And that's what each share is worth. So Tom to Adam is 3 to 7. So we have to do 3 times 24, which is 72. And 7 times 24, what's that, 168? So initially that's what's happening there. And then afterwards they sell some, and Tom buys some stamps from Adam. And now it's in the ratio of 3 to 5. So we'll do the same process again with this one. 240 divided by 8 is 30. So now we've got, Tom has 3 lots of that. So he's got 90. And Adam has 5 lots of that, which is 150. So you can see that both of those differ by 18 when you subtract them. So that's the change in the number of stamps. This is a sample. This is a stratified sample. So the 50 people are representing the total from the gym. So if we look at the sports bag, we have 17 here out of the total 50. And then we scale that up to the 700 people. So we can divide this. 5, so that gives you 14. 17 times 14, 238 sports bags. Let me just double check that on the calculator. 17 over 50 times 700. Yeah, 238. Write down any assumption you made and explain how this could affect your answer. So if you imagine that he's sampling 50 people, we have to assume when we do this that 50 is a representative sample, which means it accurately represents the actual results that you would get. So it could be that, I don't know, if you did that on a Sunday night, that doesn't represent what people truly believe for the rest of the week. So that's what we have to assume when we do this. So how this could affect your answer? Well, it would change the number of bags that he would have to get. He might have to increase them or decrease them. Here are some graphs. Let's just zoom out a little bit. Write down the letter of the graph that would have the equation x cubed. Well, that's f. That's f there. And 1 over x, that's d. So you have to learn these equations. This could be like an x cubed, but x cubed doesn't have these turning points here and here. It just kind of goes up like that. The nth term of a sequence is 2n squared minus 1. The nth term of a different sequence. So because it's a different sequence, we can't actually equate these two. That won't work. We have to actually just work out a few of these terms and see what what the pattern is. So what we can do is do 2n squared minus 1. So when n is 1, then we get 2 lots of n squared minus 1. Let's just use our calculators to do this. We've got the table function. We're going to do 2x squared minus 1. And we'll start at 1, finish at, say, 10, and step up at 1. So it goes 1, 7, 17, 31, 49, 71, etc. And for the second equation, we've got 40 minus x squared. So that one's going, the second one is 39, 36, 31, 24, 15, 4, and then it goes negative. So what you can see here is that 31 is the only one that appears in both, and that as this first one is increasing and the second one is decreasing, that means that there's not going to be any other solutions to this, and not going to be any other numbers that are common to both. Okay, I'm going to use our calculators for this one, but the mark scheme will probably want you to write this out in full. So 3.42 times 10 to the negative 7. We can just divide the numbers separately. So let's do 3.42 divided by 7.5. That gives us 0.456. And then we have 10 to the negative 7 divided by 10 to the negative 6. So we're going to subtract those, but it's minus 7 minus 6. So that gives us 10 to the minus 1. So in total, we've got 0.456 times 10 to the minus 1. We have to have it in standard form, so we've got to make this 4.56. So we multiply that by 10. And that's going to decrease that by 1. So we could just check that on our calculators. 3.42 exp to the minus 7 divided by 7.5 negative 6. 0.0456, which is that. Yeah, perfect. There is a calculator mode on your calculator called SCI, SCI. If you want to investigate that, take a look. Okay, question 8. Number of days it will take to build a house is given by that formula. Ali's company will take 40 days. Yeah, we're going to rearrange this. N equals 720 over number of days. So that's going to be 720 over 40, which is 3618. If we cancel those, 3618. Yeah, and for Haley's company, it will be 720 over 30, which is 24. So Haley's company will need to subtract those two, and we get 6 more workers. Question 9 is a surface area question, and it says that the total surface areas of these two shapes are equal, and then we need to look at the volumes. So let's work out the surface area of this cuboid. 6 times 8 will be the front face, so that will give us the area of the front face, but there's one at the back as well, so I'm just going to multiply that by 2. Then we have this side here, so that would be 18 times 6, and there's 2 of those, and then I'm going to add that to the top, which would be 8 times 18, and there's times 2 of those. So when we add all of that together, 12 times 8 plus 12 times 18 plus 16 times 18 is 600. So the total surface area is 600 centimeters squared for the cuboid, and we're told that the surface area of the cuboid is equal to the surface area of the cube. So that's going to be, surface area of the cube is 6, let's call the sides x. 6 times x squared, because each face is x squared and there's 6 of them. So that equals the same as the cuboid. So x squared is 600 over 6, which is 100. So we now know that the sides are 10 centimeters for the cube. So let's have a look at the volumes and compare those two. So the volume of the cube is 10 cubed, which is 1,000. And the volume of the cuboid is going to be 6 times 8 times 18, which I doubt is 1,000. 6 times 8 times 18 is 864 centimeters cubed. So Janet is incorrect. You might need a little sentence explaining that. Make k the subject. Okay, it's under the square root at the moment, so let's square both sides. 2m minus k. Add k to both sides. And then subtract y squared. Like that, for 2 marks, not too bad. Box plots is for GCSE and not IGCSE, but let's just have a look at it anyway. Megan says that half of the potatoes weigh less than 50. Well, this bit here is the median, and that's above 50, so she's incorrect because the median is higher than 50. Amy also grows potatoes. Compare the distribution. So when you're comparing the distribution, we're looking at the ranges. Megan's is 21 to 3 up to 72, and this is 23 up to 70. So the range for Amy is less. That only goes from 23 to 70, so that's a range of 47. This is a range of 49, I think. And then you can look at the medians, and the interquartile ranges is the best because it shows the spread of the data. So you can see that from Amy's, this is the lower and upper quartile. So that's from, say, 35 to 51, which is a difference of 16. And this one goes from 39 to 65, which goes up by, take away 40, is 26. So there's a bigger spread of the data here. So you could talk about the interquartile range for Megan's data, her potatoes being wider than Amy's as well. Find the size of angle EAD, that's that one. And E is the midpoint of that. Okay, so we're going to use some trigonometry here to find, we always look for the side that's common to both triangles that we're looking at, which in this case is BD. So there's our angle, 40 degrees. So BD is the opposite. And we have the hypotenuse here. So we're going to use sine 40 is equal to the opposite, BD, over the hypotenuse. So BD equals 8.6 sine 40. DE, we're going to make a new triangle now. So this one here, let's highlight that triangle here that we're going to now make. But we need half the length. So DE is half the length of BD. So we can just half that. Let's make that 4.3 sine 40. I've just halved that whole thing. You might use your calculator to do that and actually use the decimals. That's absolutely fine. And then we're trying to find theta. We now know DE, which is the opposite, and AD is the adjacent. So we're going to use tan theta is equal to the opposite DE over the adjacent 4.4. and then we're going to shift tan that, or the inverse tan of that answer. The only reason I'm doing that is because sometimes we use the decimals, we round it too early, and we lose marks later on. So just double check this. We've got 8.6 sine 40. We divide that by 2 to get DE. Then we divide it by 4.4, and then we take the inverse tan of that answer. And we get 32.1 degrees to 1 decimal place. Okay, Secure invested in a savings account for 3 years, compound interest for the first 2 years, and then another percentage for the 3rd year. At the end, we had that amount. Okay, this is quite a different question to what we used to. So we could do the first 2 years. Let's do our formula for that. 3,550 times 1 plus the percentage over 100 to the power of the number of years. That gives 3736.9998. So when we multiply that value, let's just call that x for now. X, we times it by a percentage for the 3rd year. So our percentage equals 3819.21. So when we take that value of 3,736 and we times it by some number, we get 3819.21. So let's divide those two. 3819.21 divided by that. So this thing here is going to be equal to 1.0219 ... So that number there that we would multiply would usually be 1 plus the percentage. So I'm going to subtract 1, and that gives me my percent as a decimal. And then I'm going to times by 100 to get the percentage. So that's going to be 2.1998 ... To 1 decimal place, that's 2.2%. Very strange question, that one. But hopefully you can see that we're kind of using that formula and rearranging it to get the percentage. Sadia is going to buy a new car. She can choose 1 body color, 1 roof color, and 1 wheel type. So there's 19 body colors, 25 wheel types, and the total number of ways that you can choose the body color, the roof, and the wheel type. So we're missing roof. That gives us the 3325 ways of combining these numbers. So we can rearrange that. 19 times 25 is 475. So 475R equals 3325. Divide those two to get 7. So there's 7 different roof colors that you can choose. Expand and simplify triple brackets. So we take a pair of them and then multiply it by the last one. So let's just choose the first two. 3x plus 2 times 2x plus 1 gives you 6x squared plus 3x plus 4x plus 2, which is 6x squared plus 7x plus 2. Now we're going to take each of those for the final bracket. We're going to do x lots of that. And then we're going to do -5 lots of that, and add those together. So what we'll get is, let's just put that in here so you can see what I'm doing. We'll get, for the first bracket, we will get 6x cubed. Let's do it to the left so you can see it here. 6x cubed plus 7x squared plus 2x. And then when you multiply by 5, minus 5 times 6x squared is minus 30x squared. Minus 5 times 7 is minus 35x. And minus 5 times 10 is minus 10. So we're going to collect all this together. 6x cubed, 7x squared minus 30x squared is minus 23x squared. 2x minus 35x is minus 33x, and the minus 10 left over. Marek has 9 cards. There is a number on each card. The product of the numbers, and work out the probability that the product is an even number. Now, if you try to do all of the different possible ways of doing this, you'll be here all day. It's best to break this down into odds and evens. Okay? Don't worry about what the numbers are. We'll just count up the number of odds. So initially we have 1, 2, 3, 4, 5 odds out of 9 cards. And the evens, 2, 4, 6, 8, that's 4. So that already breaks down our question into a more simple question. And then what we're going to do is decide on how we're going to do the next part. So if we multiply these together like odd, odd, even, even, odd, even, like that, work out the probability that the product is an even. So we can go odd times odd is odd, odd times even is even times odd is even, and even times even is even. So we can either work out all of these three and add them up, or we can do 1 minus the probability of getting odd times odd, which is actually a bit more efficient. So odd times odd, we would have 5 ninths times 4 eighths. That would be the probability of going odd then odd. And I'm going to do 1 minus that. So 1 minus 20 over 72. 72 over 72 minus 20 over 72 is 52 over 72. That's a lot quicker than doing the 3 ways of doing even like that. Okay, circle theorems. We've got a tangent going to the center, so that makes that 90. We need to work out the size of angle CAB. That's that one in there. So you should be able to see that we need that angle in there because we've got the 90. If we can work out that angle, let's call that X, then we can take it from 180 and the 90 and we'll find out theta. Because we have a circle here, this and this are both radii, so that makes that an isosceles triangle, so that's X. And that means we just need this angle in here, which we can find if we know that one. So we'll do 90 plus 32 is 122. Subtract that from 180. That gives us 58. So this is 58. That makes this one 180 minus that, which we just did, is 122. And then that means the 58 that remains is shared between the 2x, because we've got 180 minus 122, which we've already done. So you can kind of see how this repeats. So 2x is 58. So x is 27. So if we want to find out theta, we can do 90 minus 27, and that gives us 63 degrees for theta. Okay, histogram. So remember, for the formula for frequency density is the frequency divided by class width. But we're already given the frequency density and the class width, so we can use that to work out the frequency by multiplying those two together. So the frequency in the first box, let's put that in here. The first box is the class width, which is 2.5 to there, times the height of 1.2. So 2.5 times 1.2 in there. The second one is 2.5 times 2. So that's 5 in there. This one is 5 times 2.8. And then the final bar is 5, 10, and halfway is 12.5 times 0.8. Okay, so we can work out the totals of all these. 2.5 times 1.2 is 3. So that one's worth 3. This one is 5 times 2.8, 14. 12.5 times 0.8 is 10. So we've got 10, 14, 5, and 3. 10, 14, 5, and 3. 10 plus 14 plus 5 plus 3 is 32. So we've worked out all of the frequencies of those bars, and it says 20% of the trees lie between 10 and 12. So we're just going to complete that last bar that's missing. So if 20% of the trees are there, then that 32 represents 80% or 0.8 of the total. So we can divide 32 by 0.8 to get 40. So there's 40 in total. 32 of them are already covered, so that means that the final bar must represent 8 on the frequency. We know the class width, so we're going to use that formula again to find the frequency density. We're going to do 8 divided by the class width, which is 2.5. 16 over 5 is 3.2. So that height of that bar has to be 3.2. So we're going to go sort of up to there. You're going to draw that with a ruler and pencil. That's your final bar. Work out the volume of the hemisphere. So it gives you the formula here for the whole sphere. So we're going to do 4/3 pi r cubed divided by 2. And we have to make sure that the radius is half the diameter. So that's 4.2 cubed. I'm going to divide the whole thing by 2. So it's actually 2/3 times pi times 4.2 cubed. So 3 significant figures is 155. Okay, we've got a bounds question here. C is 10.9 correct to 3SF. So we're going to go up 0.05, sorry. So C can go down to 10.85. And that can go up to 10.95, like that. If I cube both of these, that will give me C cubed. And then if I divide by 8, that will give me D. So I'm going to do both of the extremes cubed, divide by 8. So that's 159.66, etc. 10.95 cubed divided by 8 is 164.11. So work out the value of D. We've had C to 3 significant figures, so we can't really go any more accurately than that, because C is at its kind of maximum, if you like, of its accuracy. And both of these extremes to 3SF will round to 160. So we would say that D is 160 to a suitable degree of accuracy, because we can't go any more accurate, and we can stay to 3SF to get D. Okay, speed time graph. Calculate the time taken by the train to travel half the distance. So how do you get distance from a speed time graph? You work out the area underneath the graph. So let's split this up into some shapes here. And the first shape is a triangle, so we're going to do half the base times the height. Half 30 times the height of, and that's going up 2, so 12 for the first one. So 6 times 30 is 180 meters. Is this meters per second? Yeah, meters. The last triangle, half 20 times 12, so that would be 120 there. And then the middle phase, the sort of rectangle here, goes from 30 to 80, so that's 50 times the height. And that would give us 600. So the total distance traveled would be 600 plus 120 plus 180, which is 900 meters. And we'd halve that to get 450 meters. So we want to know the time it takes to travel 450 meters. So we've already traveled 180 in the first 30 seconds. So I'm going to subtract 180 to give me 270. And that 270 will lie in this middle phase of the graph. We just want to know how far that would have gone. So 270, we need another rectangle here to estimate. Well, we can actually work this out. 270 meters, how much of a width would we have to go to get 270? So let's say it's there. We know the height is 12, and we know the area needs to be 270. So we can do 270 over 12, and that will tell us the width, which in this case will be the time. So 270 over 12 is 22.5. So we've got the 30 seconds to travel 180 and another 22.5 to travel the final 270. So we add those together to get 52.5. 52.5 seconds. Compare the acceleration of the train during the first part with the last part. So from a speed time graph, the gradient is the thing that gives us the acceleration. So just looking at those gradients, you can see that the second one here is the steeper one. So we can say that the acceleration is greater. If you wanted to back that up with some numbers, then you would look at the change in y divided by the change in x. So 12 is the change in y divided by 30 for the first one, and then 12 divided by 20 for the second one. So 12 over 30 is 0.4 meters per second squared, and 12 over 20, 0.6. Well, it's a negative, so minus 0.6 meters per second squared. So you can compare those two accelerations using numbers as well. Oops. For question 22, this is strictly for GCSE. This isn't IGCSE, so don't worry too much about this question, but I'll take you through it so you can prepare yourself for the further math that we're going to do, where we do iterations. Essentially, what's happening here is that we have a number of rabbits. At the end of March, there are 200. So at the end of, let's say that's March, at the end of April, it's going to be 1.2 times 200 minus 50. We can work that out. So 1.2 times 200 minus 50 is 190. So March, April, May is going to be 1.2 times April. So this new value that we've just found out, that gives us 178. And then June, we do 1.2 times 178 that we just worked out, minus 50. 163.5 0.6. Okay, so that's iteration. You're just taking the answer from the last calculation and putting it back in. If you want a shortcut for this, for those of you that are doing GCSE that might be watching this, you can actually just put 200 into your calculator, press equals, and then do 1.2 times the answer button minus 50. So if you do that, you can just keep pressing the button and you can see what happens to this over time. If you do that enough times, you'll see that this kind of becomes negative after a few months. So that's kind of what they're looking for part B. Considering your results, suggest what will happen to the number of rabbits on the farm after a long time. So we can't have negative, so you assume that the number of rabbits will become 0. So you could say that they'll die out, but something along those lines of the number of rabbits will go towards 0. Okay, 23, the diagram shows a parallelogram. Find the area. Okay, so area of parallelogram is base times height. So we need that height there. So let's draw another triangle here. 150 minus 90 is going to leave 60 in there. And this is the hypotenuse. We want the adjacent, so we're going to do cos 60 equals the adjacent over 10 minus x. And cos 60 is a half. So I'm going to times both sides by 10 minus x, and cos 60 is divided by 2. So that gives me my A, the height of the parallelogram. So now I can do the 10 minus x over 2 multiplied by the 2x minus 1. Let's just put that over 1 so it's easier. And it says that the area of the parallelogram, which we've just worked out, is greater than 15. So we need to try and rearrange this to get the thing that we're after. So let's times both sides by 2 to get 30. That clears this denominator. And we have a double brackets, 10 minus x and 2x minus 1. So we're going to get 20x minus 10 minus 2x squared plus x. So we're going to rearrange this. Take the 2x squared over the other side and we get 2x squared. 20x plus x is 21x, but I take it over the other side to get minus 21x. And minus 10 over the other side becomes plus 10 to give me plus 40. And the sign is that way round. So if you want to, you can rearrange that to make it look exactly like the one over there, but that's the same thing. Find the range of possible values of x. So we've got a quadratic inequality here. So we're going to solve this and then see if we can see what's going on with the graph. So on our calculator, we can solve this to negative 21 and 40. It gives us x equals 8. So let's do x equals 8 and x equals 5 over 2. So that's what happens when you solve this. But we can't just obviously go straight to that. We need to either use a quadratic formula or you can factorize this. If you know that one of them is x equals 8, then you could probably do x minus 8, and that would leave, we'd have to have a minus 5 there. Just check that works. Minus 16. Yeah, that works. So you can work backwards once you know the x values. Okay, so let's just draw a number line here. And we have 8 and 5 over 2 is 2.5. So let's just put that there. This is a positive quadratic graph because we've got a 2x squared. So we know that the graph is going to do this kind of thing. Okay, and so we can imagine that it's going like this. If the number line represents the x-axis. And we want to know when the graph is less than 0. So between 2.5 and 8, you can see that this graph is underneath here. But it's a less than, so it's going to be an open circle here and here. So we just need to represent that as an inequality. So we're going to do 2.5 less than x less than 8. Okay. Don't forget that on your calculators under menu B, which is the inequality, polynomial degree 2, and in this particular case, we have option number 2. If you can see that, ax squared plus bx plus c is less than 0. We put in our values, 2x squared, negative 21, and 40, and the calculator will tell us the final answer of 5/2 less than x less than 8. So don't forget to double check that on your calculators. Question 24, let's just zoom out a little bit. We have a reflection in the line x equals negative 1. So that's here. So let's put that in the correct spot there. Followed by a rotation. Okay, we've got invariant points here. This is GCSE only, guys. So I'll just go through this. But what that basically means is that 2 of the points would end up in the same place. So how could we rotate that shape and put only 2 of these back in the same place? So what we could do here is put our tracing paper down and see what points we could do. So let's experiment. I mean, if you put it up here, you could see that that would rotate. If I go clockwise, that would put that back on there, or maybe down here like that. There's a couple of different options there where you could just put the tracing paper and yeah, that would put maybe, let's see, these 2 points here would go to there. So you can see 2 of those. If you put it here, for example, and rotate it at 180 degrees, all of the points would be back on the same place. But this wants only 2 vertices, so you'd have to go into the one of the other spots that I've kind of indicated there. Okay, question 25. This is the last one. So we've got some coordinate geometry again. Let's just get it into the form of y equals mx plus c. So 2y equals minus 3x plus 17. Divide by 2 to get that. So that's our first graph. Let's try and plot an approximate graph there. Something like that. So this is going to go through when x equals 0, y is 17/2, and it's a negative gradient. So it's going to do something like that. Let's work out these points. We've said that's 17/2. And this point here, when y equals 0, we're going to put 3/2 x. Just rearrange that. Times both by 2. X equals 17/3. So this point here is 17/3. The point A has coordinates 0, 2. Let's make that a little bit lower. That's A, 0, 2. The straight line M, so this is L. The straight line M is perpendicular to L and passes through A. Okay, so let's try and draw that. Perpendicular to L, let's do it at a right angle. It's going to be something like that. Yeah, we're going to need the equation of that line. So the gradient of M which is the green line, so the gradient, perpendicular gradient for m is going to be the negative reciprocal. That just means reverse the sign and flip it upside down of this one. So reverse the sign becomes positive, and flip it upside down becomes 2 over 3. Okay, and it passes through 0, 2, so that's the y-intercept. We've already been given the y-intercept, so it's going to be y equals 2/3 x plus 2. That's the equation for line M. Okay, line L crosses the y-axis at point B, that's there, and L and M intersect at the point C, so that's there. Work out the area of triangle ABC. So they want the area of that triangle there. At the moment, we have because they cross perpendicular, so there's a little right angle in there. And we need the height and the base of the triangle. So we actually need to find out point C as well. Goodness me. Yeah, there's no other way of doing that. So simultaneous equations, or we can substitute for y, because we've got y equals in both cases. So I'm going to do 2/3 x plus 2 is equal to the original equation minus 3 over 2x plus 17 over 2 times everything by 2. 4/3 x plus 4 equals minus 3x plus 17, and then times everything by 3 to clear all these fractions. Minus 9x 51. Rearrange this. 13x equals 51, take away 12 is 39, so x is 39 over 13 is 3. Y equals 2/3 of x plus 2. So that's 4. So when x equals 3, y equals 4. So C is 3, 4. Now, hopefully, we can work out the area of that triangle, because the perpendicular height and the perpendicular base, so the area is going to be equal to 1/2. So to go from the pink line to C is a distance of 3, and the height of that would be from A to B. 17 over 2 minus 2 is 6.5. Let's see what that is. 1.5 times 6.5. 9.75 units squared. Okay, that's a ridiculous question, but it is the end of the paper, to be fair, so it's going to be hard. Hopefully that makes sense and that's useful to you guys. Good luck in your real thing in January.